Thank you so much. It's great to be here. And I'll do my best to follow these three excellent presentations that came before me. And I'm looking forward to this afternoon as well. Yeah, so I'll just jump right into an outline of my talk, which will begin with some uninspiring motivational quotations. Then I'll basically be talking about two experiments that I have run with some collaborators at Stanford, one of which involves generating image captions based on vision language models and interrogating some behavior of the models that are used for that purpose. And the next, the other experiment involves actually investigating and profiling the contents of images that are not labeled and that don't have any metadata directly associated with them. And then also investigating how various culturally specific concepts may or may not be present in the digital representations, and particularly the numerical representations you get from AI models when they're asked to profile those images. So first, just a couple of quotations. I figure if it's an AI conference, I might as well begin with something from Philip K. Dick, the sage of the future, or at least one future, from his book Scanner Darkly. Because part of what this talk is about is this pretty long-running quest I've had now to see what a scanner actually sees, to investigate what a scanner actually sees. So what is a scanner? Well, it's a metaphor in the novel. It's a ubiquitous surveillance device that is used to keep track of people and is quite technologically advanced. We might have scanners around on our persons right now, actually. But I won't get into the other plot points of the novel involving drug abuse in Southern California. But certainly the question of whether so if we take the metaphor of a scanner to be more of like an AI vision model rather than just a camera, there's a question of how deeply does it see? Does it see culture? Does it see semantics? And if it does, or if it doesn't, then are we cursed? I don't really believe that if the scanner doesn't see it very well, then we can't see well either, and we're out of luck. That doesn't. But on the other hand, at a superficial level, I was riding in a Waymo robotaxi a couple of days ago, and it occurred to me that if this thing doesn't see better than I do, then yeah, I may very well end up dead this way. Then the other quotation is from Professor Rich Sutton. It's a few years old now, but it's called The Bitter Lesson. It's this concept from AI research that really is talking about how recently most breakthroughs in AI have come from building models that sort of teach themselves or that learn by being given a general framework and just a whole lot of data, rather than being given specific knowledge, domain-specific knowledge. And so I think this is maybe more relevant if you're talking about learning chess or Go, or even natural language, than say really more culturally specific domains like art history. But it's still worth thinking about, and it's maybe sort of a concept to argue against in our work. Although after you go through this sort of depressing set of steps, then you do get to this acknowledgement that when you're talking about actual lived experience, actual cultural forms are irredeemably, or I'd say at least irreducibly complex. And so the larger point maybe is that AI agents are now being built in ways that can to some degree make some sense of that irredeemable complexity of cultural materials. But yeah, I'll just jump into my first experiment here, which involves this notion of dual conditioning, so using images and text to inform captioning of images. One motivation for doing this work is that is just to produce captions for materials, especially to be used in teaching, that are just images. They're there are various important mandates to follow these days regarding whether captions just need to be that state that captions need to be provided for those people with vision impairments, especially when working with educational materials. So to investigate that, we kind of started with a pretty contrived data set that isn't necessarily something you might teach with, but it might be. It's not something we're teaching with it right now, but it is relevant. And in this case, it's actually a large set of Japanese art from the Library of Congress and the Metropolitan Museum of Art. These are both open access data sets. It's about 6,400 images. And just what we can see from this is kind of an idea of what a spreadsheet exploring this kind of captioning approach might look like, where you have the image and, well, there is actually a description. We'll get to that in a second, but there's a notion that you're using a couple different kinds of models to produce captions based on the images. Yeah, we'll get back to this in a minute. But this is work I did with my colleague Lindsay King, who's our the head librarian at our art and architecture library at Stanford. So what we can see here, this is an example I find very interesting because of what it says about the biases of the initial training data of the model. And in this case, this is the Quen model, or the Chen Quen, actual model from Alibaba Cloud, which is you could say maybe it's a bit biased towards Chinese sources, but I doubt it. I think it's just the nature of the training data like you find on the internet. So when we give this model, show the model just the image, it says, oh, this is a traditional Chinese illustration depicting the dragon being the color performers. But then if we give it the metadata that came with the image, so ignoring, this is actually like a ground truth. This is the original curator's description of the image. If we ignore this, but we give it some other metadata, like the fact that the title of the print, the date, then it kind of backs off from the the idea that it's necessarily a Chinese illustration, because it is actually a Japanese illustration of a Chinese dance, or of performers doing a Chinese dance, coded dance in 1850. And then finally, when then we can incorporate the actual human caption, and then we get some really good alt text. Although the question is, which of these do you use for the caption for the alt text? Because they're both relevant and they both say important things, but that's kind of a curatorial question. But just to get into the specifics of how this works, this is where the dual conditioning comes in, because we're showing the model, both the original image and the metadata kind of gets pushed into the user prompt that include the title and the date of the image. And then the way these systems tend to work these days, these models work these days, is you can give it an item specific prompt or a user prompt. But then there's also a much larger system prompt, which is just a general script that and role that you're expecting the model to play. And some of those can get very long. So we follow that. This is generally good practice is to share that somewhere. Of course, you probably can't see the link from where you're sitting, but we share the text of that on a GitHub site so everyone can see it. The issue, of course, is anytime if you update the model, you probably have to change these prompts because the model no longer behaves the way you want it to. But the system prompt can say things like, I don't think I have any. No, this has a little bit of the system prompt. This is actually a user prompt, but you can see the kinds of things you have to say, like do not mention proper names unless they're included in the information, that kind of thing. So that's how these work. And so we just have a few more examples showing the interesting interplay of the underlying training data of the model, which again we saw with our chatbot example in the first talk today. The models can be quite knowledgeable, but their knowledge is based on the present day and on what they can find online. And the ways of dealing with that, one way of dealing with that is to actually fine tune the model, where we actually give it the correct culturally reflected captions as examples, and then use that model just for this collection. So by process of transfer learning. The other approach is to just use the model out of the box, but give it a conditioning, which is just contextual information only in the user prompt, in the per item prompt. So those are the two different approaches. Here we're, all these examples are really just using that second approach of conditioning with the prompt and the image. So again, we have a case where seeing the image only, the model just assumes it's a Japanese woodblock print of a samurai on horseback. One thing it doesn't know is that this is a collection from the Library of Congress, which is heavily interested in Japanese depictions of American visitors in the 19th century. So this is not a samurai on horseback; it is an American soldier holding an umbrella. But when we include metadata, the metadata that also is available to describe the image, then we get a much better or more accurate caption of the Japanese print depicting Americans holding an umbrella. Here's another example. This is an image from a collection at Stanford, the Wiley Wong collection of May's studio photos of San Francisco Chinatown. So this is a large photographic collection that I think was rescued from a dumpster and digitized. It was about to be thrown away. But it's another case where the catalog description is pretty accurate as an actress in a costume with water sleeves. But the core model, it just says this is a traditional Chinese woman in elegant attire. So again, it's lacking some important context. So this is a theater performer with this particular kind of costume, traditional water sleeve costume, or you can call it traditional if you want, but it's really just a theatrical costume. So this kind of shows some of the considerations that we had to bring into this kind of work. And then so I'll move on to this second question, which I think engages more with the notion of what the scanner sees. And this I'll just narrate some research that actually grew out of this conference at the National University of Singapore last year, which was hosted by the Department of Japanese Studies, and particularly was interested in the concept of Ma. It was primarily focused on the performing arts and music. Beng Chu Lim was one of the main conveners, and it makes sense. Ma kind of, you could say, originally derives from the mismatch between even odd-numbered poetic syllables and the 8-count rhythm of no theater music, and the need for a pause for a gap within the performance. But certainly it can take on a much larger valence in art of various fields. And I thought it would be interesting to, very naively, I mean, this is not my field anyway, but to see, like, can we actually see Ma in visual art? And before I got to that, went into that, I did looked at the state of the art. This is a couple of years old now, or at least a year and a half old, but it is still kind of the state of the art of when you incorporate visual styles into art. It often is in a generative framework. And this is a project out of Sakana AI, actually, but it's a Japanese studies researcher, Taran Kleinenwatt, did a lot of this work. That involved training a generative model on a whole lot of pretty diverse Japanese art. There's Nihonga, there's Sumie, but there's a whole lot of woodblock prints too. And you can get, based on a prompt, then you can get it to draw, pretty reasonably Japanese-ish art. Again, it doesn't quite get the feet right. That's always a part of generative AI. And very different style, different anime styles, steampunk, POA, modern with some modern touches as well. Which is all interesting. And it's certainly a fun project, and the models are free, open on Hugging Face as well. You can use these as you like. Obviously, the synthesized text inscription tabs are leave much to be desired. But I kind of I thought I saw more benefit to inverting, as the title of my talk suggests, this kind of generative model to do more introspection into what the model is seeing, what this kind of model has to learn from its training data, and then what it could actually see from existing images. And we heard in the previous talks about how AI models can be applied to images to extract features which are meaningful. Here in this case, we're using particular kind of model that some of you have probably heard of by now. This is kind of the obligatory photo showing how a contrasted language image pre-trained model works, where basically it's given a whole bunch of text and images that are matched. It converts both into some vector of numbers, like 1024 numbers for each that are correlated by their by the dimensions. So dimension 1 is correlated to dimension 1 of the images, correlated to dimension 1 of the text through 1024, and you learn these. So the model then, through the magic of neural networks, learns some semantic correlations between visual features and text. Certainly text tokens, but eventually groups of text tokens which start to look a whole lot like actual concepts. So we built this visualizer. This is mostly my work, although it grew out of some work that my colleague Peter Leonard started a while ago. That involves, first of all, building a search engine just based on these clip embeddings. So you can search any particular text. So initially, these models were really only conversant in English, but fortunately, people came along and made multilingual versions. And we even have a specifically Japanese trained model. And so so you can search for assuming you didn't have any labels. Obviously, there are labels for these images, but the actual search results are not using any of the text. They're just using the visual contents of the images. Sorry. To find all the mountains or images that match, that resonate with the concept of mountain. So it's a great way if you have a large image collection that isn't captioned. It's a very useful tool. This is actually, clip models are by far applied the most commonly in medical imaging analysis, because with X-rays you don't have what you're looking for is a way of labeling the where the bone is broken, and obviously for the training data, you do have to start with a bunch of images of broken bones and build the knowledge from there. But in this case, so the model has never potentially has never seen these images before. Although that's debatable in a lot of cases because the training they're public images and probably were vacuumed into the training set for a lot of these anyway. But at least you get a way of exploring a large corpus of images. So this is 6,400 images, like I said. They are open access. I did have to go through them one by one and make sure there weren't any. Well, I had to remove all of the erotic. You can say, well, shouldn't I use the clip model to do that? But again, this is the issue of AI and trust. If it misses one and that shows up in a talk, then I'm like, no, that's still a problem. But anyway, so getting to the question of what the model can see, what the scanner sees, there's this approach called class activation mapping or gradient class activation mapping, which just highlights the parts of the image that resonate with the search, with the search text. It doesn't have to be text, actually. You can say what parts of this image resonate with this other image, but I haven't done that here. And you can do text and image if you want, but right now I'm just using text. So this is pretty straightforward version. This has been improved a bit. There is a link down here to the most recent project from 2025 that's called clip surgery, actually. But one thing they added was they threw in a segment anything model. This is a model from Meta that just is able to segment anything as they claim, although it does struggle a bit with especially Sumie but the ink brush drawing. But it's finding in this case it's doing a good job. So it just pre-segments the image and it says of these red hotspots, which ones are encased within one of these segments. So that must be what we're looking for. But there are other. These are some other examples. So this is getting to the objective of the MA conference, which was I wanted to see if I built this kind of system, what does MA look like? You might I theoretically it could work. It's pulling in a whole bunch of conceptual associations. There's certainly negative space, but also just a particular historical aesthetic that might be resonating as well. Certainly the scroll format comes up a lot, but at least it's an attempt. Well, the fun thing here is that we're looking for something that is kind of a negative visual representation. It's something that you shouldn't be able to see exactly, or if it's like negative space, it's it is the part of the image that allows you to focus on what's actually there. But in this case, that's what we want to highlight. I have a couple of other there's several other concepts that are mostly associated with Japanese art that we could look into, like oku, I think this is, which is the like notion of interiority, or like being inside sort of hidden away in a space like an alcove. And there's several others that I could have gone into, but don't include here as a canned prompts. But so you can see what's happening here with the model when we ask it to highlight what it finds, representative of negative space is to some degree the negative space of the blank space, and the especially the border of the image. If you run the segment editing model, it does kind of exclude some of the actual illustration, because that's the non that's a part of the you can draw your own conclusions about that. The other thing to note here is that it's split into 3 tiles. This is kind of getting into the details of how these models see, and this is the kind of thing that's important to know, but is often difficult to learn unless you really dig into the technology about what the image model is looking at. And it turns out that this is a vision transformer model. Most vision transformers only look at a square. And so you have to do something to the image to allow the vision model to see the entire image if it's, for example, a long vertical scroll. So we have options here. The vision mode, you can tile it, or you can stretch it, basically. Or you can just crop it, in which case you're only looking at, we have an example here, I think, yeah. If you crop it, yeah, you'll get an answer for the whole image, but of similarity. But then if you investigate it, you realize, oh, it's only looking at this part of the image. The much more standard behavior is to stretch the image. The tiled approach is a lot more work, because you have to run the model 3 times in this case, and like average the results together if you're doing the similarity comparison for navigation. But it is more accurate, I think. But that's just something to be aware of when you're asking yourself what the scanner sees. How does it see? I'll skip most of these. We don't have to dwell on the details, but this is how a vision transformer works, is by cutting the image up into patches and then running a whole bunch of multi-layer, and it actually turns the image into an entirely one-dimensional vector, which is a very strange idea for vision, because we see vision as a 2-dimensional space, generally, and that's how previous models worked. But then for this model was actually inspired by the text transformer, which is how ChatGPT works, which pays attention to, it gets its power from being able to pay attention to where words are positioned within a sentence, or within a very long paragraph. So they thought, researchers at one point thought, well, this works so well for text, let's try it for images, and it turns out it does work really well for images. The interesting thing, this is getting back to the bigger lesson, is that this is not based on any neural analog in the same way that the previous computer vision models, the convolutional models, were based on notions of how the visual cortex works. Here we kind of just assume, well, maybe there's something in the brain that works like this, but no one really knows. But it works better. That's the amazing thing. Okay, but it's just some final observations. I might be able to do a demo even of the. This is where the demo is running. It's just running on a computer on my desk back at Stanford, so it can easily be overwhelmed, but it's still working for now. But getting into the multilingual or cultural valence question, here we're using mClip, which is a multilingual model, so it's not specifically tuned to Japanese, but it includes a whole bunch of languages. And when we search for this character, what we get is a whole lot more interior illustrations of rooms, which I think is just because it doesn't know I want the Japanese ma, it thinks I want the Chinese jian or something, which is like rooms or apartments or whatever. So this is, which I think is an interesting result. I think it kind of gets to this point. I think as we're learning with these systems, that when you're doing semantic search, you can't just do keywords. Usually, you need to kind of tell it a story. You need to. And if you don't do that, then you get a lot of noise. But in this case, it's kind of interesting noise, because it's showing you that this character has multiple meanings, or a different meaning depending on what language you're in. But it also brings back, as a counter to the bitter lesson from earlier, I say a better lesson to take is that specialized knowledge can still matter when you're working with AI systems, maybe even training them, and when you do that, you can get some interesting results or insights. So in this case, I've decided to prompt it with a haiku by Basho, and it does fairly well at finding the woman under the blossoms who is drunk and holding a sword and wearing a jacket. Oh, it doesn't. I mean, there's no illustration of that specifically, and it has the usual problem with is this a male actor playing a woman, or is it just a male actor dressed as a woman, or is it anyway? There's some confusion there, which is somewhat intentional. But for the J-clip model, for the Japanese trained model, it does do this better, and it's interesting to look into why. And particularly if you go to the homepage of the model, it was built or trained by a company called Hakuhodo Tech. And they mentioned that they used the stereo captions, which is a data set containing, at the time, 820,000 Japanese captions, specifically of images and again, these are not terribly profound captions, but it is, I think, through this, there's a very kind of arcane process of the model learning all of these, 1,000-dimensional correlations of concepts, which eventually, if it works right, can get us to the point where even an elusive aesthetic concept like Ma can be interrogated with this kind of model across an image set. So that's it for my talk. I think I might try, if I have a couple minutes left, to do the demo. Okay. There's just one piece I wanted to demonstrate that was a late breaking feature. So I'll just go to the M-clip model. I hope it's still awake. But let's just say I search for new. Yeah, so I'm searching for this in English. I did this one before, so I knew I'd get this. I don't know what's up with this bird actually. But this is a good one. So we could actually ask you to explain that one, but for now I'll go to this one, which is a little bit more representative of what we're finding. So if you go to the explain this button, it does take a little while, but it is so the similarity of results come up very quickly because those embeddings are pre-generated. But if you ask it to visualize the results by comparing this particular prompt against query text, against the image, it takes a while to do that. So you can see it is finding the snow, and maybe the darkness. And then if you segment things, it's like, yeah, hey, there's snow up here. And then finally, way at the bottom, hidden, of course, by the I need to exit. Wait, what's that? Oh, maybe I'll look at this one. Sure. Wait, so it's recalculating the actual activations of the resonances in the image of this particular prompt. So if I'm able to scroll all the way down to the bottom, okay, here we go. So this one, it just the segmentation doesn't always work well, especially when it's doing a three layer thing. But I'll try this last step, which is to calculate and it'll give you the text. The text importance will show you which of the tokens or words from the text are the most resonant with the images. This might be a bit slow, so we'll just let it run. And okay. Let's see if it actually. Oh, no, I think it's showing the. Oh, here we go. Okay. Yeah, maybe you can see that at the bottom of the screen. It's a little bit. This is the problem with the layout I've used. But you can see, it finds snow at the very bottom here is has the most but dark, cold. Although so it does a pretty good job of showing you which stories are the most relevant. So again, this is a set of tools that I think is useful for exploring these aesthetic categories and thinking about how AI models went even just out of the box, trained on thousands of images, millions of images, probably from the internet, can do certain things, but then if you incorporate more domain-specific knowledge, they can do more. And in particular, within a library context, the ability to search this kind of data set or image set when it's not well labeled is certainly interesting. And I think you'll see a lot more semantic search interfaces and systems becoming available for this kind of work. There are already some that are online, and I think it's a very interesting application of the technology. And I'm grateful to have been able to talk to you about it today.